Okay, hi guys. So in this lecture we'll be going to talk about a new topic. So that is expansion. Okay. So let me put down the heading: ring expansion. In this we are basically going to talk about we are being given a carbocation and adjacent ring. So what will happen if, let's say, we have a carbon atom which is substituent to this ring, and this CH2 has a positive charge on itself. So what actually happens is ring expansion is said to happen in wherein what happens is this bond shifting from here to this carbon takes place, resulting in a 5 carbon chain and a positive oops, and a positive charge on this carbon atom. Okay. Oh, sorry, this carbon atom. Okay, and why does this actually happen? So as to reduce the strain. So we know that for no, carbon chain has less strain than 5-member carbon chain, which has less strain than 6-member carbon chain, and obviously 6 is the most stable. It won't go next to 7. So just remember this rule of thumb, that whenever we have a 4-member ring and on a substituent on a 4-member ring we have a carbocation formation, then the 4-member ring will go and uh, have a ring expansion to have a 5-member ring, and then the 5-member ring, if possible, will go to have a 6-member ring, or a 5-member carbon ring having a substituent, and on that substituent we have a carbocation, then that 5-member ring will convert into a 6-member ring. This is called ring expansion. Okay, the ring expansion takes place when positive charge on carbon is there outside the ring. Okay, ring expansion takes place when carbocation is outside the ring. So what I mean by this is, uh, actually if we have something like this, then in this case actually no expansion won't take place. We have to have the carbocation outside the ring. Okay, so now let us take another example wherein we have something like this. Five-member ring, and we have this substance here, and in presence of inacidic medium we heat this substance. So what will happen is we will get a carbocation at this position, or better let me draw like this. Now what will happen is, again, ring expansion will take place, in which this bond would be breaking up to create internally positive charge here and positive charge here and a negative charge here. Okay, and now this negative charge in this carbon atom will form a bond with this positive charge. Okay, so what will happen is this carbon atom gets the positive charge because of bond breakage between this carbon atom and this carbon atom. Now this carbon atom and the previous carbocation join itself to form a bond, and two substituents are here on this carbon atom, and there comes a bond between this carbon atom and this carbon atom, which is already there, this bond. Okay, so I have drawn bond A here. Okay, so how many number of carbon atoms are present in this new formed ring. 1 2 3 4 5 6. Okay, so a cyclohexane is formed in which this carbon atom has two substituents and this carbon atom has a positive charge. Okay, now what happens is this carbocation has 1 2 3 no 3 1 2 alpha hydrogen, so we will have 1 2 CH3 minus shift, and due to that shift what we will get something like this, where we get a positive charge here and a substituent here. Okay, now what we will get is a double bond between this carbon and this carbon. So this is the final product which is formed. Okay, so what was the substrate? This was the substrate and this was the product. Okay, so we saw the substrate undergoing ring expansion, and that ring actually goes to CS3 minus shift. Okay, and then we get the product. Okay, so all these things have to be kept in mind whenever you are making any product from a substrate. So you have to roll through all of the possible situations that can happen in a substance or a substrate, and in the intermediate process you have to think of whether ring expansion can take place, CS3 minus shift or H minus shift can take place, and form the most stable intermediate in the RDS process, and then only decide for the product. Okay, so now let's take another example. We have something like this, and OH, and we, in the presence of H plus, we heat it. So what would the product from, or let us talk about the intermediate, positive sign and a cyclohexane. So I have given that 6-member ring will not convert into 7-member ring, because 7-member ring actually has more strain than 6-member ring. Hence, this conversion will not take place even when we have carbocation attached to a substituent on a cyclohexane ring. This ring expansion will not take place. Instead, we will get H minus shift, because presently it has only 3 plus 4 alpha hydrogen, and if we get the positive charge here, we will get something like 1 2 3 4 5 6 alpha hydrogen. Now if we actually expand further, this is H minus shift, and if we actually expand this positive charge or have a H minus shift again from here to here, so this carbocation will again have 1 and 2 3 alpha hydrogen, only 3 alpha hydrogen from the present 6 alpha hydrogen. Hence this H minus shift, more H minus shift on this compound is less likely to happen. So in this only, will after the HSO4 minus comes into the picture, we will have this as the major product. Okay, let's talk about another example. Here we have something like this, again H plus, we heat it. What will happen is we will get something like this. Now what will happen is ring expansion will take place. This is a ring expansion, not resonance energy. Okay, so what will happen is this bond will go to attach with this carbon atom. Finally we will have something like this, positive charge here and a substituent here. Okay, now next HSO4 minus comes into the picture to form this as the major product. Okay, Okay. Oh, actually, I'm sorry, I actually forgot. uh, how this is the major product. You can calculate the number of alpha hydrogen here, and two products can be formed here, right? So I guess you are able to identify what is the major and what is the minor product on the basis of number of alpha hydrogen on the alkene uh, group, or the double bond group on between those two carbon atoms. Okay. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing more such examples of ring expansion, and we'll continue on from there on. Okay, so till then, good luck and goodbye.